this is the last session about graph theory, and next time I see you we're going to do matrices. So this is actually a really good link, because believe it or not, graph theory and are actually matrices. Which is a bit crazy. So this graph can, let's put it this way, this graph can be represented as a matrix. And the matrix that represented is called the adjacency matrix. Okay, so how do we do that? So we've got A, B, C, D, E. So what I write it here. These are also big. So I'm going to write A, B, C, D, E. I'm going to write it here as well. A, B, C, D, E. Now it's quite important, mainly for like test reasons, to make sure you work alphabetically. Okay, you will see why in a second. And then I will draw this matrix kind of thing in here. And then all I'm going to do is realize that each edge can be an element in the matrix. What do I mean? So, is A connecting to B? Is there an edge between A and B? Yeah. There is. So, when I put A and B, I'll put a 1. Okay? Is there connection between, actually A is connected to all of them. A to C? Yes. So, I'm going to put 1. A to D, yes. A to E, yes. Okay? We're not all going to fill it with 1s. You will see a bunch of zeros. Now, actually, is A connected to itself through like a loop? No. So we're going to put a 0. Right? Now, is B connected to A? Yes, we already answered it. So we're going to also have a 1 here. B connected to B not connected to itself, so it will be a 0 here. B connected to C. Is B connected to D or E?
It's connected to D, but not E.
No, D.
It's connected to E.
It's connected to E, but not to E. So it will be a 0 here and a 1 there. Brilliant. And then you get the picture. Okay? C is connected to A, to B, not to itself. You'll see what I mean first in a second with to itself. Okay? Is it connected to E? No. So, sorry, it's not connected to D or to E. And then D is connected to A, not to B, not to C, well, not to anyone else, just connected to A. And E is connected to A and B, but nothing else. That's it. That's the adjacent matrix. So what you'll find also if you do math in university, you'll see, you come across things that are very, very different, like graph theories and matrices, and realize actually mathematically they can be linked. There is, the word we use is, there is isomorphism. Isomorphism. There is isomorphic graph, so I could, for example, take that, D, and put it there. That's the same graph. There's no difference here. Yeah, so that's isomorphic, but actually there's even an isomorphism between whole of graph theory and matrix. So certain things that you want to prove in graph theory and you don't know how to, you can just prove that matrix theory and then it works out that way. Okay? Now, in a test scenario, I can ask you two things. I can give you a graph and then you draw the matrix, or I can give you the matrix and you draw the graph. Okay? So let's just do that now. Just pause. Alright, so now I've got a matrix, okay? And we need to draw the graph. Now normally in a test scenario they're not always going to give you the letters, so you're going to make them up. But try and keep it alphabetical so it's easier for the marker to see it. So let's start with A. So we'll put an A here. Who is A connected to? We'll look at this row here. Who am I connected to? B and C. So we're going to put a B there. And what does that 5 mean? We didn't have any numbers here, so there's already one big difference.
It's 5 connections.
It's not 5 connection. So on the edge itself, we'll put the number 5. Do you remember what we call those? Because here we didn't have any numbers. But if you remember already the last video we did about the Chinese postman, and actually also the Jicastra nearest shortest path, we call these weighted graphs. Okay, so already one difference between these two matrices is you see that here's only 1's a 0. These are either an edge or there isn't. Here the edge has a number, so it's weighted graph. Okay, that could be, for example, is there a friendship connection between people? So A is friends with everyone, D is only friends with A. But here this could be like distances between places or time or amount of money you have to pay to get from one place to another. So that's the first difference, weighted graph. Right, A is connected to B. A is also connected to C. So I'm going to make another connection C. Okay. I'll put a 3. A is not connected to D. So I'm going to put a D here. And now it's not connected to A. Now I've got B. Check this out. Again, something weird. So when I wrote the first connection between A and B, I've got 5. But now when I'm looking at the second row, B and A, I've got a 1. So we got to decide, is it 5 or 1? There's 2. Okay? So there's 1 which is, so 1, if I go from, let's say, A to B in this direction, it will cost me 5 rand or 5 minutes or whatever. But if I'm going from B to A, this direction, it's going to be 1. Okay? So there's 2 words that I can describe here. First of all, it's this graph has multi-edges. Okay, there's more than one edge between 2 vertices. And also we can call it directed graph, because it depends in which direction we go. If we go from A to B, it's 5. From B to A is 1. Right, so now we've got another one. What does that mean, 1 between B and B? There's a loop. Okay, so that's called a loop. Okay, we put a 1 to it. Okay, so yeah, we'll summarize everything at the end. And then B is not connected to C, B is not connected to D, C is connected to A, and now I've got 1. Okay, so I've got another connection, another multi-edge, this is 1. C is connected to C, so we've got another loop here, which is 1. And C is connected to D, 2. D is only connected with C. So that's the graph, a little bit squashed. Okay, we're almost there, we're almost finished. So the main differences between, we see, I'll just kind of recap everything here. This is just 1s and 0, and all the diagonal here is all 0. What does it tell you if all the diagonal line is 0? What do we not have in this graph? What do these zeros mean? We don't have all zeros. What was that 1, 1?
You don't have loops.
Okay, so that's how you can tell from a matrix if the graph, the associated graph, has a loop or not. If this is all zeros, then there's no loops. That's it. If diagonals are A to A, B to B, exactly. Okay? We will talk about diagonals when we get to matrices next year, not so much this year. So we don't have loops here. The fact that we only have 1s means that it's not a weighted graph. Here we have more numbers than 1 to 0, that means it's weighted. And the fact that, how can I tell that this matrix has multi-edges? How would you how can you, just by looking at these two matrices, how can you know that there is no multi-edges here, and here there are multi-edges? What are the difference between these two graphs? Without looking at the graphs, so between the two matrices. Here there weren't any multi-edges, and here there are.
The numbers change, so like B A connecting to B is different.
Correct. And another way of saying it, and that will connect us really nicely to our next topic, is these graphs are symmetrical. You see, it's symmetrical. Where this graph is not symmetrical. Okay? This is symmetrical, but this bit is not, and this bit is not. If it's symmetrical graph, then you know there's no multi-edges. If it's not symmetrical, there are multi-edges. That's it. Okay? And just to add one little thing, if you have a graph where there are no loops, no multiple edges, and it's not weighted, we often call it simple graph. Okay? So really the hardest bit about graph theory is the fact that you're bombarded with millions of types of graphs and names that you have to remember. The math itself is like grade 4. Math 3. That. We're just adding numbers, that's all we do. Okay, but, so that's called a simple graph. That's it.